the name of this talk, you know, I was in the middle of 5 or 6 things, and Nate needed a name now. Nate said, now you give me a name, and I said, all right, more ways to tango. It's just the first thing that came to mind, to be honest. There's going to be nothing about dancing here. I can't dance. I don't dance. But we're going to talk about loops, and that's going to be kind of fun. But first, we're going to talk about the problem. You know, there's all kinds of ways that we could go talking about iterators. I could sit up here and write complex iterators, and we could have a whole blast with that. That could be fun. I don't know that it would be all that helpful, because iterators end up being kind of useful for a particular thing that you're trying to do. You know, and eventually you'll probably be able to build your own as you grow in Python. But you'll end up using them, and they undergird everything that you end up doing multiple times. That's the problem that we're trying to solve. And there's multiple ways of solving that problem. There's not just loops. So let's first describe the problem. Problem number 1 is you have a variable, and that thing is called A, and it has a value of A, right? And we know if we run this thing will print out A. Nothing crazy here, okay? Now we have 2 things. We have an A and a B, and we want to print both of those things out. And this is rather annoying, because now, you know, we have 2 things, and we have to type out print twice, and that's, you know, carpal tunnel's a real thing. We don't want to get carpal tunnel, and I have to print out, I have to type print twice. And if we had a C and a D or a Z all the way down to Z and then beyond, and then you get into AA and AB and AC, and it just goes on and on and on. And that would be miserable. You could not write a program like that. You could write a program like that, but you wouldn't want to write a program like that. So when we have logic, business logic, that we need to do multiple times, the first thing that we can grab is a loop. There are other options here. And so I'll try to intersperse kind of basic level things like this is what a loop is, all the way up to some of the more complex things. You can solve all the same problems with recursion. If you're into that kind of thing and you want to write functions that call themselves, you can solve all of these problems with recursion. We're not going to do that today. When we take questions, which at any time if you have questions, then feel free to ask them. Go ahead. What is this? This is a wonderful tool called IPython Notebook.
No, I mean right here where it says IN open parentheses cell.
Oh, that's I'm sorry, yes, that's the cell. So this is IPython Notebook. It's a way of executing Python code in kind of a more visual format. Where you see the word in is the start of a new block. In the square brackets is the execution number. You'll see it increment as I go on and on. Actually, if I jump all the way back up to this one and then execute again, you see that one jumps to 3. So you can follow the execution order in which I've run these. Does that answer your question? Okay, great. So I have some definitions here for what a loop is, and these are going to be kind of our working definitions. So a loop is something that you do over and over again until a certain condition is met. A loop is a predicate, protected, repeated logic. Yeah, there you go. That's about as terse as I could get it. I was like, I think I could get this down to 5 words. Let's do it. And it's not 5 words. But a loop is predicate, protected, repeated logic. What does that mean? Let's put this into a sentence. Until you have 10, add 1. All right, I wrote this sentence kind of funky. It was written differently before, but it groups a little better if you write it this way. So the predicate is until you have 10. That's your predicate. That's the thing that says, that's the thing that's going to be the conditional. That's what you're going to check for. That's what you're going to say. If it's this, if it's 10, that's your logic, so to speak. Right? That's the business logic we're trying to implement. We're trying to add some numbers together. We want to see if they're going to be 10. And then the predicate is that, and the logic is going to be adding 1. Right? So we have 2 things. We have something that we want to do, that's the logic, and then we have something that's going to tell us when we're done doing that thing. That's the predicate. Make sense? Great. Wow. Okay. So I have here the most basic way to implement this with the least amount of syntax. That's what I was going for here. Least amount of syntax, the least amount of Python niceties over the top of it, which we'll get to in a minute. This is as simple as you could possibly get it. And in most languages, I think JavaScript has a while loop, right? I see how often I program in JavaScript. It's fantastic. JavaScript has a while loop. If you jump into other languages, C, Rust, sure, all the other C-based languages, Ruby probably has a while syntax. This is the most basic type of loop. Actually, you can implement all loops as while loops. If you won't care to do that, I don't know why you would, but you can. So this is our business logic here. Our predicate is implemented on the one line with the while right here, and our logic is right here. Add one to that number, and then do it all over again. Okay, everybody knows what a loop is. We don't need to go too deep. And then this prints out 10 individual things. Okay. Okay, so loops in Python. So as you can see, leaving aside recursion, there's two options. You have while loops and you have for in loops. Right? Whiles allow you to define an arbitrary predicate. They allow you to describe the logic that you want to continue to do, or the condition in which you want to use to check when you're going to be done doing what you need to do. These are really powerful when you have to loop forever. You can't loop forever in a for in unless you create an infinite generator, and we won't get into that. But you can in a for in loop. But whiles are your best bet if you want to loop forever. All right, so you'll most likely see for ins the most in Python because they're useful for all kinds of sequences in iterators, which is what we're going to get into. But whiles absolutely have their place. All right, and then you have for ins, which let's dig into this little tidbit here. Because they solve a particular problem in Python, which is you have these things that need to be iterated over. So let's say you have a list of some kind. We all know what a list is, yes? I don't know how low to go, right? And so a list is a collection of homogeneous data. So numbers, all numbers. You have a sequence of numbers, 1, 2, 3, 4, 5, okay? For ins create an assignment from an iterable and automates the predicate, right? So you have an assignment expression. We'll dig into all of these in a minute. You have an iterable and you have the predicate, okay? This is how if you look in the Python documentation, this is the syntax for a for statement. These are, if you can learn to read these actually end up being helpful because while this isn't, to my knowledge, a standard, it might be grammatical standards for how to define languages. This kind of stuff can actually be helpful because you'll see this in other places in Python. For example, if you're looking up something like how to use a context manager, you'll realize that you can have a with, an else, and a finally. Rather, a try except block has a finally. Actually, now that I think about it, a with expression has a finally, right? Yeah, doesn't matter. So you can read these things and find all the niceties which Python has by understanding the grammar of the language. That's what this is here. So what we see is we have a for, the keyword for. That's what's in the quotations right here. The for. We have a target list. We'll get to what that is in a minute. We have the keyword in, an expression list. We'll get to that in a minute. The colon symbol, suite, and then else, and then suite, and we'll break all of this down. So the list of items, so let's get into this ends up rendering into something like this, right? So we have 1, 2, 3, 4. We want to do something over all of them. In this case, we want to print all of them. So we create the list and then we for in the list of items, take that current item and print it, okay? So let's break this down just a little bit further. We have this thing of an expression list. An expression list is the iterable that we're going to iterate over, right? It gets evaluated once, and we'll see why this is a big deal later. An iterable, an iterator gets evaluated once and only once. It's not happening multiple times, and there's a number of gotchas with this that we'll get to in a minute. It's only going to get done once, and it has to return an iterator. Absolutely has to return an iterator. Now, a lot of your built-in collection types, like a list, a tuple, a dictionary, and a set, all will automatically do this for you. It's actually happening underneath the scenes. It's creating that iterator for you. Yeah.
Did they start at one?
For what?
For your for.
Right here.
No, you count the number, you started like, from 1, 2, 3, 4. So,
Yeah, so are you referring to this right here?
yeah, those positions. Position 1 is index.
Yes, so there's a difference here between the actual position and the actual number. So for example, I'm gonna change this just a little bit, and that'll help. So if I have list of alpha, all right, and I'm gonna say that this is A, this is B, and this is C. Okay, this is index 0 right here, but it's item A. This is index 0, but item 1. Okay, great. So just to demonstrate the point of an expression list has to return an iterable, we're going to try and do this little silly thing right here. For x and true. Let's say we wanted to create an infinite loop. This might be a way a beginner would try and do it. For x and true. That wouldn't be the end of the world to think that that would be possible. It is impossible, and that's because we get a type error that a Boolean, which is the true there, isn't an iterator. Booleans don't implement the iterator protocol, which we'll deal with what all those words mean here in just a minute, okay? So this has to return an iterator. And an iterator is something that we can loop over. That's going to be our working definition for now, okay? Yeah.
What's the difference? Because these terms keep coming up. What's the difference between an iterable and iterable?
Yes, I had the definitions in here, and they, you know, because the actual, it looks like they got stripped out at some point in my verbiage typing, and if they're not right in front of me, out of sight, out of mind. So an iterable is something that can be iterated over, like a list. Yes. An iterator is an object which returns an iterable. Kind of the semantics are important because one has state and one doesn't. One has state and one doesn't. One is something that you a sequence, for example, a list of things. You can iterate over that. It is an iterable, and the list type is an iterator. There's a fair bit of complexity in that, and I think I'll explain it as we continue to walk through it. So there's three main things: an iterable, an iterator, and then an iterating, like the actual action of iterating. Okay? Does that help, Alex? Is that useful enough? Is there a better? Does somebody else want to? Yeah, go ahead. Did I? That's entirely possible. I often swap them. Wait, Bill, can you?
Iterable would be like a list.
Yeah.
An iterator is
The instance.
thing that walks.
Okay. Yes. Bill is the one that I think I've given 6 of these talks, and it's always Bill who ends up saying, "No, Nick, you have that fundamentally wrong. Why don't you try again?" Thanks, Bill. I appreciate that. So now let's talk about this little piece right here, which is this thing called a target list. Okay, so for x in 1, 2, all right, we're looking right here. X is the target. X is a variable, and that's going to be an assignment operation. Ultimately, Python is going to take whatever value we're currently at, the 1, for example, the first time that we're going through this list, that integer 1 is going to be assigned to the x. That's going to be an actual, ultimately, I believe it ends up being an expression in the Python world. It ends up being an expression, and that allows you to do all kinds of nifty things, like be able to unpack tuples and various things like that. But we'll get to all that later. So this ends up creating an expression list, and there's some gotchas here because if you want to do something like this, which is possible, there's just something really little that's wrong with this, and it looks really right. If you're new to Python, this could look right to you. But there's one problem, is that you can't unpack the iterate. Bill, correct me here. The iterator, iterable. I'm going to mess it up unless somebody makes sure I say it right. The list here, though, the list object's going to return a iterator. Yes. The thing that has the state, iterator. Yes. Okay. So the iterator here, the list object right here, the iterator, right? It's going to return something, and that is going to be a 1 every time, right? It's going to be a 1, and then it's going to be a 2, and then it's going to be whatever else is in the list. You can't unpack a 1 into an XY. There's only one option here, right? There's not 2. Yeah.
What do you mean by unpack?
Sure. Yeah, that's probably a good question. So when you're dealing with something like a tuple in Python, you can do something like, let's say you have a Cartesian coordinate, and it ends up being right here. But let's say you end up having an X and a Y. You can actually unpack this like this, and this is a valid assignment expression, right? So, and you can do this with all kinds of things. Actually, we'll see this in a minute with when you're looping over something like a dictionary. So let's say you have a for key value in, I'm going to use shorthand here for dict, A, B. You're ultimately unpacking, sorry. What you're doing is you're taking the result of the call to items and unpacking it into the key value, because items will return a tuple. Okay, so you can do that with a whole number of things. Does that make sense? Okay. Okay, so you can't, this one right here will throw a type error, and this is the type error. Int object is not iterable. You can't iterate over an int. So what we actually learned from this is something important. The tuple unpacking that I'm talking about is actually the action of iterating over a tuple and unpacking it into an assignment. Okay, so that's under the hood what's actually happening when you unpack a tuple. You're actually iterating over the tuple. Okay.
I got a question.
Yeah.
So for the very first example you give, is there a reason to prefer a list over a tuple, like just a single tuple?
Like right here?
Yeah, like is there a preference or a recommendation?
Yes, never do this. Yeah, and here's the reason why. Because you shouldn't really be for looping like this over a heterogeneous data structure. So a tuple by nature is not designed to be a list of numbers. A list is for a list of numbers. A tuple is more for something like you're going to have a number, and then you're going to have a list of something, and then you're going to have some arbitrary object, and you want to find a way to group them together, heterogeneous. When you have a list of numbers, that's a homogeneous data structure.
Yeah, I heard that tuples are immutable too, while lists are not.
Yes, yep, that's also true. Yep. Yeah, in this particular circumstance, it's actually not going to matter because the tuple underneath is going to return an iterator, because I'm going to try to say it right. Okay. Any other questions? Right, so this loop, this thing right here that I've been talking about, this is what it ultimately is equivalent to. The loop is equivalent to signing x, y equals to 1. That is invalid Python. You can't do that. Okay, you can do that. That's legal. That isn't. Good? Not good. Terrible? No.
You have to separate X equals 1 from Y equals 1.
Yeah, so the reason why this isn't valid is because you don't have enough variables you don't have enough values to unpack into the variables. You don't have enough things to bound to those names. Does that answer the question? I don't know if that answers. Okay. Yeah.
So like it's trying to find a value for X and a value for Y, but there's only one value, which is 1.
Correct.
You would need another value for the Y.
Yes.
Okay.
Yeah, and so you'll get issues like this. Type error int object is not iterable, which doesn't exactly, once you realize what this means, it ends up being obvious, but right away that's not exactly obvious. Why the heck is there a type error? Why is this? That doesn't seem to be like a type problem, but it actually is because your data structure is wrong. It's a type. Correct. Right. Yep. And that left side is going to take dominance. Now there's I don't actually know if this will work because in Python 3 you'll have, yeah, that won't work because you can do things like this as well. And if we inspect X here, and this is actually good because this is an example of what?
You're only going to get Y that sells on the current Y.
It should print both. It should, yeah, it should print both. Yes. So, so what you can see here is this is some special syntax, and I didn't look it up, and I'm not going to pretend to know. Somewhere in Python 3, one of the dot releases, they brought the asterisk to unpacking. And I believe you can actually do something crazy like this as well. I don't really use this all that often, but I believe this works. We'll find out. Learning together, something like that. Yeah. So you can do really crazy stuff here. This is all under the hood using the iterator protocol to be able to manage all this stuff. Yes, sir.
Isn't the asterisk usually used for multiplication and powers?
Yeah. So the star symbol there is overload to use a number of things in Python. One of them is multiplication. Another one is to unpack or pack variables into structures. So you'll see this with when you define certain types of functions. You'll see this kind of syntax pretty frequently. And this, I didn't even think about all these use cases of iterables, but this is all iteration underneath. So if you say, you create your function, my function, A, B, this is normally written as, something, and then this is going to be args, and you'll actually see this as well. And what this allows you to do is be able to pass arbitrary number of things to a function that you wouldn't be able to know about ahead of time. So I'll give an example of where this ends up being useful. Just a minute, that you can see it. So if I call my function here, this is all iteration underneath. Function, is that right? Yep. So this is going to be something. And then we're going to pass 1, 2, 3, 4 of these. And then we're going to say do thing equals true. Okay? So this prints out that. So something is assigned to the string something. Args takes everything that isn't a keyword. Right? And then quargs is everything that is a keyword. So we can start passing arbitrary things into this. Other thing equals false. And we'll start getting all of these. This is like how powerful Python ends up being. This ability right here is what empowers the language. And stuff like this is incredibly powerful. Yeah.
So how exactly is it?
Yeah, so there's semantics behind it. So the ones that don't have, so you can also have defaults in here, and I'll just for completeness. Oops. And you're seeing why that fails, and maybe I should go into why that fails, and I will. Let's see, so that's going to go. I'll print that out just so you get the point. So we'll start messing with these and show you what works and what doesn't. Things I wasn't planning on talking about. This is great. Just so that this is a little obvious. Okay, so we can arrange these things in, I think, only one other way. I believe args can move to the end like this. And that's the only other thing that we can do. We can do what I had before and this. So something in this case is required. If we try to execute this function without a something, we should get a type error. It says you're missing one required positional argument. So that's what that first one is. That thing's a positional argument. Okay. The next thing is there's a final thing keyword. I don't know that there's really preferred order. Does anybody know of a preferred order to this? I don't know that like PEP requires anything. What? Yeah, that's true. That is true. That's actually a great point. So it's going to matter what you want to do. Yep. So in this situation, the one went to final thing, right? So this is ultimately going to, who asked the question? There, the fellow back there. So this is going to ultimately mean what do you want to do? Argument to be final thing, then put, let's say you wanted to write, I don't know, an add. an add that also had the ability to multiply by 2. I don't really know, right? We could write a function like that, I suppose. Add or multiply, and it takes an arbitrary number of arguments and multiply equals false. And then we could, I don't know, we could do, let's see here. So for x in args, x plus, what did I use? I guess we could just simplify this one. If multiply returns some args, also uses iterators underneath, else return, let's see here. So it's going to be if multiply else. Oh, sorry. Yeah, if not multiply. Don't do live coding, folks. If then we're gonna, let's see here. So it's going to be x times times 2 for x in args, and then we'll actually just sum this whole thing, all using iterators underneath, and then add or multiply 1, 2, 3, 4. This gives us 10, which is 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, right? And then maybe we do something like this. And we get 20. Okay, so all of this underneath is using the iterator protocol to pull in args. Args is being unpacked into an iterator in the sum situation here. So sum is a built-in function that allows you to take an iterator and sum the results of it. It has to return something that implements the dunder add method, but that's irrelevant. Okay, so carrying on here, showing the unpacking thing. So you can unpack lists of tuples into x, y. So to solve the previous problem that we were talking about whenever we were talking about it 10 minutes ago, this is how you can ultimately solve that problem. So you have a list of tuples, right? We could have another one in here that's maybe 2, 3, and then another one which is 3, 4. And you can get the whole result of it, okay? Okay, so the suite is the going all the way back up here to our definition of what a for loop is. The suite here is whatever business logic you want to implement, which we've seen plenty of that. So I don't know that I need to talk about that. So what about when we're done? So there's a couple ways, there's a couple semantics that Python gives us to be able to deal with the done condition. And these are some things to note about. So if the list executes without a break statement, else will be called. And almost all other situations, the else won't be called. So unless there's a break, else is going to be called. Okay, so let's see what this means. So we're going to print out all these numbers and then print complete the loop. Nothing special there. Note here, complete the loop is called. We passed it an empty list. Now note that nothing got printed out because it was an empty list, but it did call the else. Now look at this one. Execute through it and only one gets printed out because we have a break in there and it fails. So now there is one little kind of gotcha, which is, oh, I think I talk about this later. I'll wait for the gotcha because it's later. There's a couple special things you can do within loops, which is can go to the next iteration early, and that's done with a continue statement. So you can continue within a loop to skip logic. So we see here for x in 1, 2, 3, 4, 5. We take the modulus of x, and then we continue if it's not even. Otherwise, this will ultimately just print out the even numbers. So we're skipping 1, 3, and 5. So we're continuing the loop early.
Did you do that because they're odd?
Yes, primarily. Yeah. I got it. That's funny.
What's the difference between pass?
So pass will let's see here. So pass within this context, I think it won't actually do anything. Continue means short circuit the loop. Pass will continue to print it out. So pass will ultimately mean just continue on. Exit early from the called function is normally what pass ends up meaning. Don't do whatever it's a way of, so when you're defining a function, the function body has to have at least one expression. Is that right? I think it's one expression, and pass completes that requirement, allows you to do nothing and complete the requirement for a function to have one expression. Yeah.
In Python, in order to designate the end of the loop, is a space. I noticed in some of the code, they have for loops, and there would be nothing at the end of the loop, no next state or anything like that. We start the next loop.
There doesn't need to be, conventionally, there's no requirement for white space. Is that what you're asking? There's no requirement for white space? Is that what you're asking?
No, I'm saying that Python doesn't have an end of the loop. Like in basic, you have for and next.
I'm not familiar with it.
What defines the end of the for loop? I believe it's the
Space.
indentation.
Yes. So the question, the concept there that you're looking for is called scoping. How do we know the end of the scope of the loop? And that within Python is done through indentation. There's no brackets in Python. If you want to, there's a version of Python where you can have brackets if you so wish. I don't know. I don't even remember what it's called, honestly. But there is a way. I believe you can have brackets in a particular version of Python.
Okay, so it's not just an empty space. You have to have an indentation. It does anything.
The lack of an indentation actually denotes the end of the loop, right? So if I was to put print, oops, hello, this is within the loop. If I put it here, that's outside the loop. So it will be executed after. The key difference here is that indentation. So Python actually doesn't care much about white space. It really only cares about indentation. And indentation is how it scopes. It says this is in scope, this isn't in scope. And the reason why I say white space doesn't matter is I can put all kinds of white space in here and it does the exact same thing. Okay? Does that help?
Yes.
Okay, so there's the special continue keyword. There's also the special break keyword. So you can terminate a loop early, and this will terminate the innermost loop. Okay? So there's a one little gotcha in here. For x in 1, this is nothing crazy. We get the 1, and then we break. We don't get the print. Note that we don't get the print in the else. This is one of those situations where you might not get what you expect. And here's why. Because when we execute this function, the print will be done. So why this matters is that you can have, if you have a list passed into a function, and that list is, you're expecting there to be an item in there, and you don't want to complete that if a break is included because some special condition met, make sure you cover your empty list condition. Because otherwise you might run into this. Situations for this, I don't know, nothing immediate is coming off the top of my head, just know that it's there. I'm trying to think if file reading would end up being a problem, but nothing's coming straight to mind. Yeah.
Shouldn't you structure it to where there's only one way in?
Yes, in one sense. Yeah, there is kind of only one way in and one way out. The gotcha here is that the break is never hit. We never actually even enter the context of the for loop. So you can't break out of the for loop early, which is the condition for not printing. Is that helpful? So yes, you really only have, the only way to probably avoid this would be to wrap it in an if. You'd have to wrap it in an if. You'd have to do this. If not list. Let's assign this to a value of L. Rather, if L Oops. That would be the only way to, I think, forcefully solve it. Anybody else think of something?
L or Y?
It's an L. I'm sorry. It's probably a poor choice here. Choose G. Yeah. It's the same thing. Say that again? Yeah. Yep.
It looked like you were assigning an array to Y.
Yeah, which wouldn't be possible. Not that I know of. I don't think you can override it. Doesn't matter. One gets created when the Python process starts. So things a for loop is used for. So we can iterate over all kinds of things. I don't know. How much time do I have? Oh, okay. So you can iterate over a whole bunch of things, like a string. A string is an iterable. Pretty straightforward. A homogeneous data structure, as we were talking about earlier, like a list. You can print over those. We've seen that all night. You can go over a tuple, but don't do this, because you don't really have a good sense of what's going to be inside of it. And really, this is more convention than anything, but tuples are for heterogeneous data, not for homogeneous data. And you probably shouldn't. You want to consider carefully whether or not you want to be looping over heterogeneous data. Yeah, go ahead, Randy.
Just, you said it well, this is convention, not Python.
Yes.
It is true though, looping over heterogeneous data is weird.
Here's why, because these things, when you're using a tuple, you want to unpack this. You don't want to loop over it. That's kind of the difference. You want to be able to say, this A has a meaning. Let's say it's your initial, and then age, and then your properties. Let's pretend that this is like a person, a tuple. Okay, and this dict would have like, I don't know, something useful about you, your social security number. What?
I just need a name to access.
Yes, true. You can. Yes. 1 sec. Yes.
I mean, I would say the reason why you would usually in the case of like you're trying to do some data, and if it's different data, then you can't want to say that.
Correct. Exactly. Yep. Yeah, you're trying to execute some sort of business logic, and you're expecting the contents of the loop, the iterator, to return the same thing. Yeah, and if it's a heterogeneous data or different types of data, then you don't have that guarantee. So convention would say you'd want to use the other one. Yeah.
Yeah, so another kind of similar question. Is there a preference between using the curly brackets and the dict keyword?
If I remember correctly, the curly braces are C Python optimized. So if you care about speed, use curly braces. Dict is useful for other things. Yep, the actual dict thing here is, I don't know why I did that, to be complete. I think I did it because the curly braces are actually overloaded to represent a set as well. Yeah, say that again.
You still have to explicitly write dict. I remember that in Python too. A long time ago.
Oh, yeah, maybe it would have to be a long time ago, at least for sure before I started. Anybody remember back in those days? Python like 2 dot something, I would think. So a dict can also be written like this, A1. If you forget that semicolon and you write, you do something like this, and you accidentally write it like this, that is actually a set. That is not a dict. Is a problem. So be clear is probably the advice I would give. Okay, great. So you can loop over hashables, things that are hashable, or not going to get into hashables. A dictionary is hashable, a set is hashable, certain types of objects are hashable, those that implement the hash method. If we take a look at this, there's a couple things here. And this is kind of interesting because we're seeing the actual value of the iterator, the capabilities of an object to return multiple types of iterators. So for a dictionary, by default, you get the keys when you try to iterate over it. So this for loop is going to print out the keys. All right, but you also have a method on a dictionary which returns a particular type of iterator, which is values. And instead of getting the keys, you'll get the values. Okay? So that's an instance method. You can also get items, which will return a tuple of the key value. If you've worked with dicts, probably know a lot of this. And you can also unpack that tuple into named keys or named values, like key value in dict items. Okay, so if we execute this, we get dict, which is ABC, values 1, 2, 3, items by default returns this, and then when we unpack it, we get that. Any questions on this? Great. Okay, so now there's more advanced things that you can start to do with iterators to begin with. Right here, I'm creating a temporary file on my local machine, giving it some data. Basically, ignore most of this stuff up here. And you can actually loop over this, and this is kind of another example of where you need to be careful about what type of iterator you're using, because you might end up getting something you don't expect. So in this situation, we're going to read the file by lines. In this situation, we're going to read it by character. And this is what we end up getting. So by lines, we get hi and new line. And by character, we get the same thing, just a little different. Any questions on that? Does that make sense? We're dealing just with a file in this situation. Same protocol underneath. The read method is effectively calling next, which we haven't gotten to yet, but we will in just a minute. Okay, so now this is probably the little bit more advanced stuff. So you can define your own iterators. You can define things that implement the iterator protocol. That protocol is very simple. It has to be an object which defines the dunder iter method and the dunder next method. Those are the two requirements. Implement dunder iter and implement dunder next. This is probably the simplest representation of this that we could come up with. Thanks to Bill for a little bit of help today. He's always stepping in to help me because this is way cleaner than what I had originally. So we're defining a new class here, a range iterator. This is basically re-implementing the Python function. And this is, you should always use the Python function here. So we could, my range, this could basically all be rewritten like this, 10. And we'll get back to the range, right? But we're re-implementing this behavior. We create the actual object, which is init. Right, and it takes an end, that's going to be the end of our range. It takes a start, that's an optional keyword, which starts at 0. This is assuming integers. And then a step, we can step by multiple things. We can step by 1, we can step by 3, 5, 10, whatever integer we want to. It defines an iter method, which actually just returns itself. We can have it return other things. We can create something when we want to iterate over, say, a file. You might want to return something that returns it by lines, or you want to return it by character. That it can return different things, okay? And then we actually return the actual iterable. This was left over from before. All right, this next method is what implements the logic of getting the next value, whatever the next value is going to be. For things like lists and dictionaries, this stuff is all built for you underneath, right? But if we want to build our own, we're going to have to build our own. All right, so when we execute this, the first thing we do is we pass in our end, and we get an object back. This is what's going to call the init method, and it's going to instantiate the object. Very similar to the, right here you're seeing this brief parentheticals, because this goes back to what we were talking about with modules. Dunder init is really for initializing things. And underneath the covers, Python builds dictionaries of all of the named values that you're using. So in a module, you have functions, and you have other packages, and you have maybe constants. You have all kinds of things, right? It's actually building up a dictionary underneath, and it's looking up the values that you're looking for. So let's say you want to call a function. It actually looks into a dictionary and says, give me the function by this name. And it returns the function, then executes it. Same thing for modules and packages. So init here is the same concept. What we're saying is, instantiate the object for me. Now there's also so again, another parenthetical for a little bit more advanced stuff. There's also the dunder new, which actually creates the object. init allows you to change the object after the object has been initialized into memory. So there's actually 2 steps here. Dunder new is how you would deal with meta classes. Dunder init is how you actually deal with the individual objects. Okay, rolling back up out of the parentheses. So if we call this is the dunder init, and then we can loop over it, and we will, the first time and only the first time, it's going to call iter, and it's going to return itself, and then over and over and over and over and over again, it's going to call next. Okay, so let's see this. And we get 0 through 9, right? So that's what we wanted. We wanted 10 items. We got 0 through 9 because it starts at 0. Make sense? Any questions? Okay, so now I kind of give you a hint here that something weird is about to happen. When I execute this, bonus points, an extra Chick-fil-A sandwich, if you know what's going to happen. Huh? Nope. Good, very good guess though. Huh? It will do nothing. Actually, is kind of the bizarre thing. I did execute that. Nothing happened. What the heck? Remember how I said iterators? I like to bill. Iterators are actually have their own state within them. What's the state in this situation? If you can read this code quickly, what's the state? What's the one thing that we're changing? Counter. We're augmenting counter. And what did I say? Iter only gets called once, and the init only gets called once. So really what this is a bug. Okay, what we need to do is whenever iter is called, we need to reset the counter. Otherwise, you're not going to get all the way back to the start. Okay, I'm going to pause. Does everybody get that? I'm going to show the code in a minute, but okay. So this is the fixed code, and I've put in some print statements here just to show what things look like and kind of offset them so you see where stuff is happening. All right, and note that in the iter, we've kind of reset our counter here. And if we run this, we see that init gets called, and then iter gets called, and then the first iteration gets called with next. And then we get a 0, and then next gets called, and we get a 1 all the way down to the end. And then if we call corrected iterator again, we actually get the values that we expect. What's the important difference? Init is only called once because we're using the same global object, but we're reinitializing the iterator every time. Okay, so iter is being called, init is not. Questions? Okay, so there's a couple things to note here. I'm going to do a brief little thing if I have another 3 minutes, 4 minutes. Oh, okay. Well, I don't know that everybody wants to hear me talk about this for another 15 minutes, but briefly, we're going to talk about some comprehension. It's comprehensive. That's good. List comprehensions. That's what we're going to talk about. Comprehensive, apparently, is what came to my mind. We're going to talk about them from a generator perspective, from a list perspective, and from a dict perspective. Look at this very carefully, and you'll note that we're using parentheses to declare something, and what we're declaring here is a generator. A generator is an iterable always, but it has some special properties, especially once you get into Python 3. Generators can be closed, generators can be resumed, generators underneath are actually this idea of threading called coroutines, and there's all this kind of rigmarole that we're not going to get into because I didn't have time to prepare it. So our range iterator corrected, we're using the correct one this time. If you note, init gets called and iter gets called, so we have an iterable, and the type of that thing is a generator. And we know that these parentheses here are what says that it's a generator. That's shorthand syntax for generator. If we wanted to do this a little differently, we could use a keyword called yield. We're not going to. We can then loop through this thing. Note what isn't called next. Next is never called, even though we see a for loop. We see a for loop, but there's no next yet. The for loop all gets called in here. We see next gets called a whole bunch of times, and then we get our list comprehension returning here. So these little things here are called comprehensions. They're one lines for dealing with iterables, and they're incredibly powerful when you need to do some sort of an assignment. So if you're trying to, I'll show you kind of what this ends up looking like. So let's say we want to do this, but we actually want to multiply it by 2 and give that to something called my value. So I'm so creative with names. Oops. Yeah, you're absolutely right. I'll just do this for now. We get the values back, okay? So now I need to get myself set back up here because otherwise we're gonna get ourselves into trouble. Now if I try to run this one right here, we're gonna get the same problem. When a generator expires, a generator also carries state. What I didn't tell you is that my RIC up here, my corrected range iterator, is actually a generator. Underneath the covers, while you don't even see a yield statement, I've basically fundamentally reinvented what a generator does. It carries some sort of state, and it is giving us the values lazily. Now that's a really naive, and when I say naive, I mean basic, simplistic definition of what a generator does, but it's gonna give you the values lazily. It's not gonna go out and do some really expensive computation 300,000 times. It's gonna do it once, hand you the response, and then wait till you want it again. Then when you want it again, it's gonna go out and do that hard thing and then return again, okay? So generators are incredibly useful when you have really difficult computations that you don't want to do all of them at once. So for example, we deal with, at level 12, we deal with a significant number of database iterations where we're going out and grabbing thousands of rows of something. Well, we might not want to grab all of those rows all at once. So underneath, the library that we use for database abstraction, SQL Alchemy, allows us to be able to grab those rows batched. I mean, we grab, we'll say one at a time. In the background, the database is actually grabbing, let's say 100 or something like that and loading them into memory. But you're getting them one at a time. You're not completely overloading Python or, for that matter, your database. So this kind of pattern of being able to defer things, put them off lazily, is incredibly powerful, especially when you're dealing with large sets of data. And underneath, it's all the iterator protocol. Now, generators have some more advanced things, like I said, being able to close them, and they're Python 3.6 and Python 3.7 that bring in the new async features of Python that allow you to have really incredible capabilities of managing multiple IO-bound tasks. You can do some really incredible stuff with this. Generators, and ultimately the much larger topic of coroutines is what underpins all of this stuff. So if we call this again, you're kind of seeing here that I'm building a dictionary, and note that it's calling next, 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 and ultimately giving us back the dictionary they want. These are the ASCII characters based off of the digit. That's nothing really special. I had to throw something in here about tangoing. There's a couple helpful things to note about iteration that you might not be familiar with. Because the Python protocol for iteration doesn't have counters by default, like in a C-style programming language you'd define, or in Java, I think JavaScript, I don't remember. You'd have something more akin to this for int I equals 0, I is less than 10, I plus plus, and then you'd have kind of the details for whatever you do, print out I think is how you end up writing it. Right? Is that, I don't know, I'm not a C guy. So because this I is what keeps the index, we don't have that in Python because we have a much simpler for loop. You can use the enumerate function to do that instead, and you will get a tuple of the index and the actual value that you're iterating over. Just to demonstrate this, you can do this with I. I is at 0 is 100, I at 1 is 105, I at 2 is at 400. A powerful little tidbit. if you ever need it. There's some really cool things that you can do with list comprehensions, or in this case, this is actually a generator expression. So a generator expression, all of these things meet my predicate. Just a fancy way of saying, is it true? So in this situation, I want to know, are any of my items evenly divisible by 2? Are any of them evenly divisible by 2? We can pass that in, and we get a single value, a true. This is actually, underneath, this is a functional way, a quick Pythonic way to be able to do reduction. You can also do the same thing with all. Again, a generator expression, are all of these things divisible evenly by 2? And this one is false. A note that some iterators are sequences, but not all sequences are iterable. Sorry, let me rephrase that. Not all iterators are sequences. All sequences are iterators. I reversed it the first time. Okay, so a list, 1, 2, 3, 4, 5, 6, 7, that's an iterable. But not all, see, now I got myself all messed up because I said it backwards once. All sequences are iterators. Not all iterators are sequences. Dictionaries, for example, are not a sequence. They're actually a hashable type. You're looking that thing up randomly. So you're not guaranteed order, is the point. They're not in a sequence. They're in memory distributed evenly. Now that's, again, for those who are more advanced in Python, you know that that's not even true. But you can see that the order here is 1, 2, 3 is how I passed it to this thing called a set, which is not a sequence. A set is not a sequence. And when we iterate over them, we get CBA, which is not the same thing as this. Which is, now a good question to ask would be, well, Nick, how the heck did you know that it wasn't going to come back in order? And for a small set like this, Python actually optimizes it, and it's always going to come back in this order anyway. But in actuality, sets are not ordered. Okay. I was going to show you a more advanced recursive generator expression, then I ran out of time and didn't get it done, but it actually loops through and calls a generator in order to print out all your paths. You can nest generators. This is just recursion, just lazily done in Python. Okay, that's all I have. Does anybody have, I know that last bit was kind of a whirlwind, but anybody have any last questions?
Recursively do that with generators, does it remove the stack limit because you're discarding and exhausting from the stack or stuff?
Geez, I'd have to think about that.
Is it kind of like trampoline?
It's kind of what?
Is it kind of like trampoline?
I'm not familiar with the term trampolining.
It's a way of doing a recursive call, but you have a recursive call, another recursive, by doing so when it returns, instead of doing the tail, it can eliminate the frame from the stack.
Oh,
So
interesting.
you just keep like
Bouncing back. Oh, interesting.
Forward instead, so you don't hit the Python stack.
Yeah, this would, I mean, I didn't obviously get it up and running quick enough, but my guess is that this would be constant memory. So I would think so, yes. Yeah, I would think it would be constant memory because you're not loading all of the references, because it has to build a reference to every path. So I'm thinking it would be constant memory, yeah. Recursive generators are kind of nifty. I wish I would have got it running because then you could have seen all the directories that I have at my. Yeah.
What about Zip?
Oh, Zip. Yeah, Zip is kind of a nifty little thing. Zip allows you to take, I'll just show this quick, two things that are of, I don't know that they have to be of equal length. I don't remember. Yeah, see, everybody else remembers the semantics more than I do. Y'all should be teaching this. So this returns a zip object, which is an iterator, and then we can turn this into a list. Like that. So zip is one of those tools. There's actually an entire, there's an entire package.
Isn't that the equivalent to multiplying?
This? Not quite. Matrix multiplication in Python is, let's see here. So I believe the syntax is this. I don't do a lot of matrix multiplication. Oh, is it at? You're right. You sure? Yeah, there's a way of doing matrix multiplication. It actually has its own dunder methods if you're interested. No. Yeah, no, I don't think that's how you would end up doing matrix multiplication.
I would just use an apply.
Yeah. If you don't care about your disk space, which most of us don't. Other questions? Yeah, zip is kind of handy. I will say the iter tools is a fantastic standard library package that allows you to do all kinds of things. There's like accumulate, chain, allows you to put multiple things together. We actually have one of our libraries that's open source for level 12 is called Blaze Utils. It is in the right spot. Blaze Utils, do I have that somewhere on here? Looks like I do. We have a whole bunch of really useful iterators that you can, or functions which operate on iterators, which do all kinds of wonderful things. Like getting the length of an iterator, getting the first value where it meets a particular predicate. Identity is not relevant. Partitioning an iterator into two other iterators. All this stuff might seem useless at first, but once you start getting into working with a lot of data that's in list form, it ends up being actually quite useful. Flatten is also really helpful. 4 or 5 things and you want to make them flat. Other questions?
Can we do a quick little experiment to clear up the confusion between iteration and iterable and iterator?
Sure. What do you want me to type?
Just do a list instead of severity. Okay, so my list is an iterable. You can iterate over it.
Yeah. Mm-hmm.
Create another variable and set it equal to my list dot under iterate. Equals thing equals. No.
I don't know. Wait, sorry, I don't know.
Thing equals my list dot under iterate. You have to call it. There we go. Okay, so we execute that. Now, yeah, so now thing is an iterator, and an iterator is something you call next on. So now you can call next on thing multiple times until you get the stop iteration exception. So you do that 4 times.
No, you
5
can't.
times.
You can't.
Yeah, you can.
Okay, I just hit it 5 times. You can't. You want to know why? Because it's.
Yeah, like put it 5 times in the line.
It's counting the 5 lines.
You need 5 lines because of how.
Oh, I see what you're saying. I'm like, no, it's not the way it works. I see what you're saying. Yes.
That's all. That's all.
Does that clear up confusion?
So it's iterable,
Was there-
iterator, and iterating.
Yeah, each of the next lines would be an iteration.
Yes.
And the iterator, which is the most confusing part for me, is the thing which you call it. And the thing
Yes.
called the class you made earlier was you created a class where the iterable and the iterator were essentially the same thing. Because you return self, iter returns self.
Yes.
So you have a class that operates as well.
Yeah. Yeah. Underneath, I was trying to overload it into be a generator as well.
Color change.
The color change?
Yes.
Probably of no significance other than Jupiter being Jupiter.
No, I'm looking at thing has black parentheses and it goes to green color.
Yeah, it's just wherever my cursor is. Yeah. Other questions? Okay, thank you. Thanks, everybody.